Hi. So, someone commented on one of my videos recently, and it kind of just reminded me that they're still there. And so, I thought I would make a new one to kind of summarize what I was trying to say before, and give you what is currently the current version of my work. Yeah, the videos that I had up there before are basically to document the progress of creating this idea, and I think what I have now is in its basically final state, until at least until I go back to school and finish my philosophy education. My formal education is in software development, and I think that kind of shows in my argument, but yeah, I just wanted, like, my old videos, they contradict one another, they're not self-consistent, and it's fairly obvious that I'm doing the research while I'm making the videos, and now I've done a crap ton of research, and this is what I ended up at, so I just wanted to put this out there. The reason that I stopped making videos is for the past several years, I've been working on healing myself. My official diagnosis was schizoid personality disorder, which essentially means I was a hermit. And that's primarily, like, the biggest symptom is a blunted affect, which is the monotone voice and just lack of emotions in everything I do. And so that's why all my other videos are so damn boring. So hopefully this one isn't quite so bad. But yeah, I'm just going to read through what I have for my current theory and the way it exists now, which is the space-time stack. So my idea is based on two of the leading scientific views of space-time, which is that space-time is four-dimensional and that the arrow of time is essentially just entropy. Where I disagree primarily with the popular scientific opinion is that I simply cannot believe that my experience of a moving present is just an illusion when it's the most evident thing we experience. As human beings, the passage of time is the most evident thing we experience. I think it's way more radical to say that the passage of time, the flow of time, is an illusion than just to say that there's a reason for it to exist. Unlike most philosophers and scientists, however, I don't think we need to get rid of either the fourth dimension or entropy in order to explain our experience of a moving present. So in terms of theories of time, I think mine is most similar to the moving spotlight theory, which is that four-dimensional space-time exists and the present just moves through it like a spotlight. But the spotlight theory of time, like the moving spotlight theory of time, it kind of requires that it all be simultaneous, which I think is just silly. Like, the relativity seems to contradict that. So, yeah, mine is similar to that, but I think it's more like a moving flashlight where every single particle has its own flashlight, and an instance of the present can spawn other instances of the present when it interacts, when changes in space-time interact with one another, with other particles. So yeah, there are many frames, small segments of time-like lines, which can be compared to one another to determine tense phrases like A is earlier than B, or Q and X are simultaneous. Similarly, I propose that every fundamental particle has its own spotlight, which covers a segment of time, but I differ in my view where those borders should be drawn and why. The main difference is that I believe there are reasons for the spotlights to exist and why they would be moving. I agree with those who say that our perceptions of the present are the way in which we interpret entropy, but I'd go further to say that entropy isn't restricted to just three dimensions and that our interpretations of it are based on actual changes in physical reality which are initiated by random events. My reasoning for the existence of random events is that it appears that our universe began with one, and I think I need to say what I think a random event is here, because it's maybe not random in the sense that it was without reason, and I really like the current interpretation of space-time in that the beginning of time is curved, so saying like what happened before the Big Bang is like saying what's north of the North Pole. But that still means that the universe is a bit of a bootstrap paradox. So to give you an idea of what a bootstrap paradox is, basically it's, okay, so I have these thumb chucks, right? They're what I doodle with now that I don't smoke anymore. And say my future self came back in time and gave me these thumb chucks, and then I grow up to the point where I go back in time and I give my past self these exact same thumb chucks, then where did the origin of them come from? And then that's essentially the problem of a bootstrap paradox, of where did the origin come from. And so saying that there's no north of the North Pole, there's no time before time, that still doesn't explain the origin. And so that, to me, counts as a random event. Okay, so where am I? Actual thing here. Okay. The reason that we perceive the present to be moving is due to this four-dimensional entropy, in which all of space-time is getting continually more complex and chaotic. Our human perceptions evolved to notice the change in movement, and it stands to reason that our perception of a moving present is the result of the same thing: movement through time of objects responding to change, which I believe is caused by random events. Such events are likely minuscule in nature and could range from the spontaneous creation of quantum particles, as Lawrence Krauss describes, to already existing particles simply suddenly moving in a different direction for no causal reason, which I think Sean Carroll is very close to the truth. The collapsing field theory of quantum physics seems like it might match up with mine, but I think that I've tried to match it up before and it didn't really meld. So I'm not sure. I just don't know enough math to be able to tell. But the idea that Sean Carroll's working on of the many worlds theory of quantum mechanics, it's kind of like that, except you only need one reality to exist, and it's just changes in time that make the difference. So each particle. Okay, so wait, sorry, where am I? Right. When this happens, those particles enter into what I call an instance of the present. So when a random event occurs, then it causes an instance of a present of the present in a particle. When that particle interacts with another particle, it causes an instance of the present in that particle, and so on and so forth. It causes a causal chain, which gives us the illusion of simultaneity. And I think that that's where the feeling that simultaneity exists comes from, is this illusion of the present. And so I think it's a mistake to say that the flow of time is an illusion, but I think it's very accurate to say that simultaneity is an illusion. So each particle has its own instance of the present, which can be grouped into instances of larger objects that consist of the associated particles over a certain period of time, using the principles of perdurance. And perdurance is basically just a way to define objects. Perdurance basically just means that we don't just use spatial coordinates to define objects, we also use temporal coordinates. That solves like the paradox of the axe. You know, you have an axe, you replace the head of it, and then later you replace the handle of it. Is it the same axe? And that it just depends on context, because we define objects using perdurance. Temporal coordinates matter. I should point out that after a random event occurs, the resulting causal chain would still be deterministic in nature, but the location of each object's here and now in this model is both measurable and important not despite, but because relativity. Instances of the present in this model move through time at the same rate as their objects do from any given perspective. So every object moves through time at 1 second per second from its own perspective, which is not necessarily 1 second per second from another object's perspective, if you know about relativity. And I can hear the presentists crying out infinite regress, saying that having a moving fourth dimension would require a fifth to track its eternalistic logic. But in this model, the fourth dimension is still doing all the tracking of movement occurring. The only thing which would need additional tracking are the random events themselves, and those are points in time, which makes that fifth dimension not an actual dimension because it's not fluid, it's a virtual dimension. And so in order to track that, I use a stack, which is a programming term. So in programming, a stack is a type of list. And it basically means last on, first off. So it works like a stack of paper. So if you have a stack of paper and you add something to the stack, it's also the first thing that you take off the stack. If you call the stack, the only thing that you can see is the top layer. So that's what the space-time stack looks like, and only the top layer describes actual existence, and everything under it is just a way of tracking information, a way of preserving information so that it doesn't get lost, because that's one of them rules of thermodynamics or whatever. It's important to note that the description of each state cannot and does not depend on some overarching Newtonian frame of reference. Everything is only being tracked from its own frame of reference. Therefore, it works with relativity. And the only simultaneous point is the point at which particles interact, which also makes it adhere perfectly with relativity. This model also represents a universe in which time travel is logically possible, because, I mean, well, time travel is logically possible in any sort of universe, to be quite frank. David Lewis solved it for completely deterministic universes, but to me, that still does mess with free will, because it's just that, not because logic, but because there's a feeling of it seems like I should be able to do something else. But you'll have to study David Lewis and counterfactuals to know what I'm talking about there. Ask me if you want to know. I'll be glad to write out a comment. But yeah, basically this is a way of doing it where you don't even need that. We still have plenty of free will. And it's just, you know, if a change happens in the future, or if a change happens in the past, it doesn't immediately affect the future because the changes happen at 1 second per second. So you would never be able to overwrite yourself by going into the past. And that's kind of the crux of the theory, and that's kind of anthropomorphizing it a bit. But I think you probably get what I'm saying there. I've tried to simplify it a little bit there, but hopefully it makes sense. So let me know.